Hello, my name is Tianhao Zhou, and my title of this presentation is using oxygen plasma treatment cobalt-based alloy to improve the adhesion strength of the hydroxyapatite coating. Okay, let's look at what is the artificial knee joints. Just looking at the pictures in the right hand, and the artificial knee joint is the knee joint which is severely injured before, and just using some metals or polymers to instead the artificial knee joints, to instead the natural growing knee joints in replacing the natural growing one, and in order to maintain the human body running. And the artificial knee joint is a structure made of specific type of alloys or plastics and able to replace natural growing bones, as I mentioned before. And for these knees, which is severely destroyed, and can help to relieve pain and restore function. An artificial knee joint is required by the aging society nowadays, as we can see. So what is the artificial knee joint needs? The artificial needs a reliable wear resistant, which is can expand the lifespan of the artificial knee joint. We don't want an artificial knee joint just to use about 1 year or 2 years and need another replacement that is hurt, and not only hurt but expensive. And the strength or toughness of the material is also needed. And toxicity, you don't want the poisonous materials to influence your human body. And friction performance, which is can influence the flexibility of the artificial knee joint. And the biocompatibility, compatibility, such as the corrosion resistance and etc. Now let's look at the 4 main materials of artificial knee joints. The first one is ultra high molecular weight polyethylene and titaniums and stainless steel and cobalt-based alloy. Okay, let's first look at the polymers. Some advantages such as the high oxidation resistance. As we can see, there's a negative material against the oxygen, and relatively low cost because the amount of the production is pretty high per year. And disadvantages such as low wear resistant and may generate particle and leads to particle diseases. Some may have some negative impact on the human bodies. And titaniums. One advantage is, as we know, is the great or the perfect biocompatibility and high wear resistant as well. And some disadvantages because of the great biocompatibility and high toughness, it might cause degenerate and fracture of bone and tissue. And the third one is stainless steel. The first one, the advantages is reliable toughness and strength, as we can see the normal steels, and low influence at human body. But there are some disadvantages as well. The corrosion problem of the stainless steel, and because of the corrosion problem, the lifespan is not always so long. And the stainless steel is always used in the hip joints, but not the knee joints, because there are differences between the knee joints and hip joints. The hip joints is much more simpler than the knee joints, and the knee joints need to cut down some bones or the tissues of the human body, and so the stainless steel is not suitable for the knee joints. And here we go, the main material of today's presentation, the cobalt-based alloy. advantages is high wear resistance, high biocompatibility, and reliable toughness and strength. But there are some disadvantages, such as the issue of the ion release and toxicity of cobalt, which can cause some heart diseases of the human body. So the surface need to be modified because of the ion release of the cobalt-based alloys. So why the surface modification is so important? In order to improve the biocompatibility, wear resistance, and adhesion property. And for those specific material to control the ion release and so that the lifespan can be expanded. And there are several modification ways of this alloy in the past. This one, using the mechanical attrition treatment, improved corrosion resistance. And this one, custom brushes, increased the wear resistance. And those two are the main researches I will explain more in the further pictures. And research design, the aim of the research is to find out a comprehensive way to improve the biocompatibility of the material, and both with the wear resistance by combining two researches. And some related work, as I mentioned before, using the HA coating, the abbreviation version, and this one, the plasma immersion treatment. Because of those two researchers have both generated the oxide layer. So we are going to examine whether the plasma immersion treatment can improve the adhesion of hydroxyapatite coating of the cobalt-based alloy. So the design is experimental design. We use mirror polished 8 pieces of this kind of alloy and discs as just like this as the sample of the experiment. The steps is first cleaned by the ultrasonic bath condition, and the second is sent to the plasma treatment process. 2 pieces of this are marked as plasma treated, and 2 pieces left metal furnace, and finally sent to the emerged into the HA powder and the solution, and then coated by the HA coating. The methodology is scanning electron microscope and X-ray differentiation, pignostic tripometer, and some human body cells in order to look at those properties of the alloy, modified alloy. Critical analysis, some advantages, experimental control group, which can make these experiments so more reliable, and various of the methodology, as I mentioned before, 4 methodologies. But there are several disadvantages. The first one is steps too much, because the research is the steps are so complicated, and possibility of fail in coding process, which is should be concerned after. And that's the end. Thank you. And here's my references. Thank you.